The railgun was supposed to render traditional naval artillery completely obsolete. A weapon capable of launching a solid kinetic projectile at Mach 7, punching through concrete fortresses from 100 miles away without a single ounce of explosive powder. On paper, it was the ultimate asymmetric advantage. But when the weapon was finally pushed into live field trials, military engineers ran into a brutal, microscopic reality that no computer simulation could prevent. The sheer kinetic energy and thermal load required to fire the weapon literally caused the barrel to rip itself apart from the inside out after just a few shots. To achieve hypersonic speeds, the system required an unprecedented surge of electrical current to pass through two parallel rails. This created an intense electromagnetic force that accelerated the projectile, but it also generated temperatures that instantly vaporized metal. Every time the trigger was pulled, the weapon wasn't just destroying the target, it was systematically melting its own structural core. The plasma arcing inside the bore tore chunks of material out of the copper alloys, drastically altering the precision tolerances required for hypervelocity guidance. A weapon designed to fire thousands of rounds over its operational life cycle was facing critical mechanical failure before it could even finish a standard testing block. Furthermore, the logistics footprint required to power the prototype was completely unviable. The massive capacitor banks and dedicated power grids needed to recharge the system could only fit on a handful of specialized surface vessels, completely eliminating the weapon's tactical versatility. It was a multi-billion-dollar engineering masterpiece defeated entirely by basic metallurgy. While the public expected a revolution in modern warfare, the military's most destructive prototype weapon remains permanently locked away in an experimental hangar, proving that on the modern battlefield, raw destructive power means